Quantum computing is becoming an ever more popular buzzword in the news and media today, but it isn't being adequately explained to the general public. So this begs the question, what is quantum computing and how does it work? Quantum computing is a complicated, exhilarating, and efficient branch of computing that focuses on using the core quantum mechanics properties to create faster computers. These properties include superposition, entanglement, and interference. Superposition is when a bit can be between two states. In order to understand this idea, you must know the difference between a bit and a qubit. A classical bit can only be one of two things, a 0 or a 1. The 0 symbolizes off, and the 1 symbolizes on. A classical computer, most commonly recognized as a normal computer, operates by having transistors that can only be turned on or off, which controls the computer and its energy current flow. A quantum computer, however, is a bit different. It operates using qubits, also known as a quantum bit, which operates as having a dial of 0 or 1. This is important because it allows the qubit to be turned between those states of 0 and 1. A good analogy would be to view the qubit as a dial and the quantum bit as a light switch. In regards to the definition of superposition, it just means that a qubit is able to be in between the two states of 0 and 1. The next quantum mechanics principle that is central to quantum computing is entanglement. Entanglement is essentially when two objects depend on each other in a way that is only possible in the quantum world. A prime example of this is shown by Schrödinger's cat. Schrödinger's cat is an imaginary experiment where a cat is placed in a sealed cardboard box with a tiny amount of poison. While in the box, the cat either dies from the poison or it doesn't. The only way to know the state of the cat, whether it's dead or alive, is to open the completely sealed box. While in the box, this means that the cat is both dead and alive, since we don't know its current state. Quantum interference works very similar to wave interference, where if amplitudes are in phase, they add, and if they are out of phase, they cancel. One-way interference in quantum computing is shown is through the noise of the quantum environment damaging the objects. The main fun of talking about quantum computing comes from discussing the different type of logic gates. The main logic gates we're going to be talking about today are the X gate, the Z gate, and the Hadamard gate. The X gate, or bit flip, allows you to flip the bit, as it would sound like. It is similar to the classic NOT logic gate. An example of its output would be taking ket 0 to ket 1, or ket 1 to ket 0. The Z gate operates as a phase gate and allows you to change the input. It is not comparable to anything classical. It changes ket 0 to still ket 0, and it changes ket 1 to negative ket 1. The Hadamard gate is when something super interesting happens. It creates a 50-50 superposition between 0 and 1. It's 50 and 50 because there's a 50% chance of it being 0 and a 50% chance of it being 1. When putting ket 0 through a Hadamard gate, it turns it to the square root of 0.5 times ket 0 plus the square root of 0.5 times ket 1. And when putting a 1 through a Hadamard gate, it becomes the square root of 0.5 times ket 0 minus the square root of 0.5 times ket 1.